Hello, in this video I want to explain torque. Torque is the thing we want to look at when we want to understand how strong a rotational motion is started or also changed. When we look at rotations and we want to calculate how strong a rotation is started or also changed, then we need to look at torques. Forces alone are not enough to understand how a rotation is started. This figure shows a door handle, and here's the axis, which we call pivot, and the rotation of the door handle happens around that pivot point. And we can push the door handle at different locations, and we always get that rotation around that pivot, but we know from experience that it does matter from where we push that force. Also, if we push straight down or maybe we push at an angle like this, and we can still rotate that handle, but the strength of that rotation is a little bit different. Let's go back and push the force straight down again and see how strong is that rotation. And we use torque to understand how strong that rotation is. And that is how torque is defined. Torque is equal to distance to that pivot multiplied with the force. This symbol down here means that this force needs to be perpendicular to that distance. And this is the definition of torque, and that's also how we calculate the torque, which tells us how strong that rotation is. When we plug in the values, we get that the torque, which is a lowercase tau, is equal to 0.1 meter times 12 Newton, which is 1.2 Newton meter. And Newton meter is the SI unit for torque. When we push closer to the pivot, then we still use the same formula there, but now we have a different R. Now the R is 0.05 meter, which we multiply with the same force of 12 Newton, which makes 0.6 Newton meter. So we see that with the same force, now we get only half the torque. So it is half as strong, the rotation, how we start that rotation around that pivot point from the door handle. When we change the angle of the force, then we have to change our calculations again. Now this becomes really important, that torque is defined as R times the perpendicular force. When we push like so, then this force is not perpendicular to that distance vector. So at first we have to split this force into two components, and we need the perpendicular component of that force and perpendicular to that distance vector. Once we split this, now we can use that formula again and plug in the values, and the calculations from before becomes that distance, 0.05 meter, multiplied with now only 10 Newton, even though we are still pushing with 12 Newton, but only 10 Newton are perpendicular to R, and the torque becomes now 0.5 Newton meter.